Okay, here are the notes for worksheet 2. Again, I didn't print this out for you, so you have time to, and you're able to pause the video, right? Copy worksheet 2, trig ratios, notes, right? Copy this down, copy the directions. Again, these problems just ask for one here. I mean, it's only going to give the answer for one on the key, but I actually want you to find all three, right? Sine, cosine, and tangent. All right, so we're actually not only going to find sine. The answer, when you check it, will only give you the answer for this function or this ratio, but you should be able to find all three very easily. So go ahead and pause it, copy this down, copy the first problem, and then we're going to move on. So pause it. Okay, so now let's go ahead and begin with this. We're going to go ahead and just write this over here as we've already covered sine, cosine, and tangent. How does so, ka, and toa help you? How does so, ka, toa help you? Remember, the first one is the function, which means that what? Sine of the angle is equal to, and the last two are is the ratio, right? O over H. That's why you get the SOH. So it's so. First one's the function, the last two is the numerator and the denominator for the ratio for your fraction. So that's sine. And then for cosine here for ka, the ka starts with a C, so C is what? Cosine. And then the last two are for the ratio or the fraction, A over H. And again, this is what we learned the last time, right? So we're familiar with this. Now the t is the function, so that's what? Tangent. And then that's going to be what? Well, the last two is the numerator and the denominator, O over A. Okay, so this is going to be pretty easy. All three sides are there. Look at what do we identify first? The sides, right? Label them. The first one that we label is the hypotenuse side. Remember, the other two, which are the legs, has the 90-degree in between the two other sides. This other one, the diagonal one, is your hypotenuse. There's H, so label it. And then very important, which one comes next? Don't mix up these next two. Look for the angle, whether it's an angle here or if it's a capital letter A or some other capital letter. Opposite, not across. Some people are going to start using A for across. No, it's O. This is the opposite side of the angle. And then the last one is A. Okay, so we're going to find, again, all three. Sine, cosine, and tangent. Even though this one just says sine, we're going to find all of them. So we know sine is, we wrote it over here, so, right? So, S-O-H. And then ka is cosine, is what? A over H. And it seems like you did this already because this is similar to what you did on the last assignment. To is tangent to O over A. What's different now, if you look at these problems, or right now when you look at all these problems, they're all going to have a radical. They're all going to have a square root, and you're going to have to fix some of these answers in these ratios. You can't leave them with the radical in the denominator. Okay, and we've seen that with 30, 60, 90, so this should be pretty easy. Okay, sine is going to be O over H, so that's sine is, O is 2 root 14 over H, 15. Okay. Always look to reduce these whole numbers. There's nothing here that can reduce. And if the square root is in the top, in the numerator, you're fine. So this answer is done right here for sine. Cosine, you see we're going to have a problem. Cosine, you're going to get A, which is 13 over H. Oh, no, actually, we're not. A over H, 13 over 15. Oh, no problem, no problem. 13 over 15. Oh, nothing to reduce. We don't have a square root in the denominator. You're good. And again, this one. Opposite for tangent opposite is the 2 root 14. Again, good news when the radical is on the top. We can leave it there. It's okay if it's in the numerator over a, which is 13. All right, this one was pretty easy. The radical was in the top. It was not in the denominator. The other problems are going to have that scenario. We got to fix it. There's nothing to reduce on these whole numbers, so that takes care of number 1. All right, go ahead moving on to number 2. Go ahead and pause it. Again, if you need to rewind or view it again, that's the advantage of the video. Okay, hopefully now you copied it. Copy this into your notes, remember? What do we do first? We label the sides. Don't just look at this blank triangle and try to remember things in your head. You're gonna miss one or put one of them in the wrong place. The hypotenuse is the one you identify first. Then draw the arrow. Get into these good habits. The arrow that is opposite or from the angle opposite as your opposite side, and then your adjacent side. Okay, so let's do sine. Sine here would be what? SOH, S-O-H, right? We've pretty much established that. Hopefully you're good with this now. So, or sine is opposite over hypotenuse, which would be 3 over, here we go, the square root of 13. Can't have that. Cannot have that. This is improper. We have to fix this. Okay, so how do we fix sine for 3 over the square root of 13? Well, when you have a radical in the denominator, remember the way you make it a whole number is you multiply by it exactly what the radical is to the numerator and the denominator. And then you're going to get sine is equal to, well, 3 times the square root of 13 in the numerator is 3 outside and the square root of 13 there. And then here, for the denominator, the square root of 13 times the square root of 13 is just 13. And then these, always check and see if those can reduce. These do not. That's the ratio for sine. Cosine, I think we're going to have to do the same thing. Cosine is ka, A over H, which is going to be what? 2 over the square root of 13. Cannot have the radical in the denominator. We have to fix this, right? This one. So we're going to multiply by what? Well, it's the square root of 13 in the denominator, the square root of 13 in the numerator. Very similar to what happened with sine, but the answers will not be the same. The ratio will not be the same. Here you're going to get cosine is 2 root 13 for the numerator over, well, the square root of 13 times the square root of 13 is just 13. Okay, that's cosine. And then now that you look at tangent over here, we know that tangent is TOA, O-A, opposite over adjacent. That's going to be what? Opposite is 3 over 2. All right, that one was an easy one. No radicals, nothing to reduce. So this is our final ratio. Okay, let's look at these last two. These will be a little bit more complicated, so keep following along. Number 3. Again, pause it. Copy the problem here, draw it out, pause it, and then I'll continue and press play when you're ready. Okay, let's move on. We got all 3 sides. You are going to label the hypotenuse, right? Label your sides. That's hypotenuse side. Opposite of the angle. Look at the angle, look at opposite of it. That's your opposite side, and the last one is adjacent. Label the sides. Don't just keep them in your head or you're going to mess something up. We're going to do all 3 again. Sine is so. right? So katawa, so is S, and then O over H. That's going to be the opposite, which is 11 over 13. All right, nothing to reduce, no radicals, great. We're done with sine, right? That means that sine is 11 over 13. That's it. Let's go to cosine. Cosine is ka. C, then A over H. Ka. A is 4 root 3. Oh, good, it's in the numerator. Whew. 4 root 3 over, wait, A, 4 root 3 over H, which is 13. Oh, good. Nothing to reduce on the whole numbers. The radical is in the numerator. That's good. So, nothing to fix. Cosine, we're done. Cosine is 4 root 3 over 13. Here's the one that is going to have some extra work required. Tangent is TOA. Starts with a T and it's OA, TOA. O is the opposite side, which is 11, and here it is. The A, which is the 4 root 3, is in the denominator. See, that's the one we have to fix. You cannot have the square root in the denominator. Not only that, but we have a number out here as well, so let's just review that again. We've seen that with the 30-60 and the 45-45-90 triangles. If I got 11 over 4 root 3, well, always check first and see if these whole numbers can reduce. They cannot. So now we continue and we look at this and we're going to fix this and do something so that we don't have a radical in the denominator. We're going to multiply by exactly what the radical is. You don't need the 4, just taking care of this. So multiply numerator and denominator by the square root of 3 over the square root of 3, which is actually just 1, right? You're left with what? You're left with tangent is equal to 11 times root 3 is just 11 root 3 in the numerator over, and here you got the 4, that's a whole number 4, and then the square root of 3 times the square root of 3 is 3. So you still got that 4, and then the square root, that's going to be just a whole number 3. These will multiply. Your final answer, your final ratio for tangent is 11 root 3 in the numerator over what? 12, right? 4 times 3, 12. Okay, last one, number 4. Okay, pause it here, copy it down. When you're ready, push play. All right, let's label the sides. Always the hypotenuse first, always. Not the one that has the legs with the 90 degrees. This is the hypotenuse. This is the opposite. That's the adjacent. All right. Sine is so, which is opposite over hypotenuse, which is going to give you, O is 9 over the H, which is 5 root 10. Can't have that, right? Can't have sine with can't have that radical there. We're going to fix it. How do we fix it? Well, I'm okay with the 9 and the 5, and always check if these can reduce, but you only need to multiply this with a root 10. You don't need a 5. Okay, what's going to be left here? You're going to have 9 root 10 over 5 times what? Well, remember the square root of 10 times the square root of 10 is 10, so it's 5 times 10. That's why your final ratio for sine is what? 9 root 10 in the numerator over 5 times 10, 50. And then again, always see again and see if you can reduce those whole numbers. You cannot. That is sine right there. Cosine, I believe the same thing, very similar will happen. Cosine is a over h, right? Ka, which is going to be adjacent. In this case, it's 13 over 5 root 10. Well, again, 13 and the 5 can't reduce. Got to fix this. Cannot have a radical in the denominator. So, again, these can't reduce. Always check and do that first if possible. We just need to take care of the root 10, so multiply by exactly what that radical is. This is going to give you what? 13 root 10, that's a 13. 13 times root 10, 13 root 10, and then 5, it's the 5 times what? 10. Just like it happened with sine. Final ratio for cosine is 13 root 10 over 5 times 10 is 50. We did sine, we did cosine. What about tangent? Remember, do all three. Tangent is what? Opposite over adjacent. Oh, we just got whole numbers. We just got whole numbers. You know what? Let me just do it here. Tangent is TOA, O over A. Well, the opposite is the 9, and the A is a 13. So guess what? That's it for tangent. Tangent is 9 over 13. Okay, that's going to be it for worksheet 2, and I'm going to have, well, the next one's going to be worksheet 3. All right, there you go.